Welcome to this third installment of the video series Which Way is Smart? Do you know which direction to take? In this third part, we're going to look at the challenging topic of smart communications. Somewhat cynically, George Bernard Shaw tells us that the single biggest problem in communication is the illusion that it's actually taking place. The choice, cost, and reliability of the communication medium and the data protocols is an incredibly important consideration, again often overlooked by utilities. Furthermore, the types of communication and where those should be applied are often very different at the different levels inside the topology. As the signpost indicates, the communication medium can take many forms. It might be mobile communication, GSM. Will it be a service-orientated architecture, SOAP XML? Will it be PLC, power line communications? Will it be optical interfaces? There's a new technology called LPWAN, Low Power Wide Area Network, which is very exciting, alternative to GSM. DLMS COSAM, a very old standard, is also an option. And then for areas where permanent online connectivity is always a problem, Wi-Fi might be used as a good backup to your primary communication medium. I suspect that of all the aspects of a smart ecosystem, the most misunderstandings happen in relation to understanding what comms actually means. First of all, let's make a clear distinction between communication medium, which is like an envelope. This is the physical way that data is transferred between AMI components. It may be along a wire, what we call wired, or it may be over the air, what we call wireless. It should be bidirectional. The communication medium requirements are quite varied at the different levels in the AMI topology, as we'll see. Then, to distinguish that from the actual data that is transferred, that's like the letter inside the envelope. We also refer to that as the message protocol, because that is how the data gets exchanged between one component and another. It's the agreed contract between the sending party and the receiving party, and defines the format that the data will be transmitted in. The message protocol requirements are again quite varied at the different levels in the AMI topology. Ideally, the same protocol should be able to be used across different devices at a given level. Standards try to formalize message protocols, but implementation choices rarely ensures real interoperability. It probably seems quite obvious that a simple service-orientated architecture, in other words, a simple request and response, is ideal, particularly across a wireless medium. However, some protocols become very chatty and involve multiple requests and responses. So we've already established that there's a difference between the comms medium and the actual data flowing across the medium. However, there's also a difference between the level in the hierarchy where that communication is taking place. If we look at the meter to concentrator level, this is generally wired. That's the recommended route. Wireless communication in the near vicinity of a concentrator and the meter just adds significant complexity to the system. But avoid creating a bird's nest or a maypole of wiring. That's why PLC actually represents a very good option in this case, because the wires are already there. Either way, it must be simple, reliable, and consistent. Choose concentrators in this hierarchy that communicate with meters from different manufacturers. That's very important. And ongoing communication costs should be zero or very low, in other words, between the meter and concentrator. I say zero because it should be wired, in which case there is no cost other than purchasing the devices themselves. Okay, so that we don't get lost, remember we're talking at the meter to concentrator level, and we need to differentiate between medium and data. We've discussed the medium part, now let's look at the data. We need to keep it simple. Where possible, use a simple request or response, what I call a service-orientated architecture. And then, in order to ensure interoperability of requests and responses between meter manufacturers, make sure that the protocol is a popular IEC standard. Hopefully you're still with me, unlike the little minion below. Hopefully not so confused that you're still following my train of thought. Remember, we need to look at comms from a medium and a data perspective, and we also need to look at it from the hierarchy level. So now we're looking at between a head-end system and the concentrator, or sometimes between the head-end system and the meter itself if there is no concentrator. The types of comms that we look at this level is normally wireless, Wi-Fi, GSM, as I say, the very exciting LPWAN communication technology, and even PLC, although that has limits in terms of distance. Far and away the most challenging and costly comms component is this wireless level. Signal strength, uptime, and available bandwidth are factors that determine the success or failure at this level. The comms complexity is always underestimated, so get expert help. Avoid having to become a comms expert. LPWAN, as I've mentioned, is a very good candidate for metrology. LPWAN is ideal for telemetry purposes such as that in remote metrology, and it requires very few base stations for a large number of endpoints. Consider support for multiple comms mediums, in other words, a primary comms medium and then a secondary backup medium that you can use when the primary is not working. Wi-Fi makes a good secondary backup medium for drive-by or walk-by data collection. And remember that comms mediums evolve rapidly. While your meter might last 10 or 20 years in the field, comms goes out of fashion very quickly. Multitasking at the comms level is also essential. You need to be able to get communication with multiple concentrators and/or meters at the same time. Otherwise, you'll never be able to communicate in a 24-hour day with your entire install base. So we've just looked at the mediums that are available in this distributed network between head-end system and concentrator. Now let's look at the data requirements. We also need to consider how long the data must be kept for, and we need to make sure that the messaging requirements are kept simple. Where possible, again, use a simple service-oriented request-response architecture and avoid chatty protocols because they take up a lot of bandwidth and it takes a long time to communicate a particular use case to a meter if you've got to involve many messages flowing backwards and forwards. Always try to use standardized and/or open protocols to ensure interoperability. You don't want to get tied into a particular manufacturer. Like the medium, data protocols evolve, so ensure that firmware updates for concentrators are supported, so that as the protocols evolve, the various concentrators can be updated to support those new versions. Keep costs low and scalability high with compact messages. The bigger and fatter a message is, the more it's going to cost and the more unreliable your communication network will be. You have to be stingy with the amount of data that you're sending. It needs to be appropriate. And then utilize appropriate data security, because you don't want people looking at or spying on the data that is flowing across the open air between your concentrator and head-end system. Star Trek's Captain Kirk understood the challenge of good communication.
Stand by to receive our transmission.
Just checking you're still with me. We've looked at comms from a meter concentrator level. We've looked at it from a concentrator to head-end system level. And now we're going to look at it from a head-end system to meter data manager level. The comms requirements at this level are different again. Remember that it's going to involve large amounts of data transferred between the meter data manager and head-end system. So it should be interoperable and it should be wired. And ideally they should be co-located so you don't have to rely on any wide area network. And of course it needs to be secure. So avoid distributed head-end system topology, as wide area networks don't have the same reliability and bandwidth. So we now come to the final part of this marathon session on comms, and that is at the data level between the head-end system and the MDM. Give preference to web service integration, that service-oriented architecture where data is exchanged via SOAP XML. Make sure that multitasking integration is essential. You must be able to call multiple services at the same time. Minimize data cohesion between the head-end system and MDM to ensure good performance and scalability so that you can change one without unduly affecting the other component. Reduce integration costs by using only a minimal number of head-end systems, which are also interoperable. You may be surprised how many proprietary or pseudo-proprietary protocols there are to choose from. DLMS COSM is a popular but unfortunately very outdated protocol because it's not based on a service-oriented architecture. A much better option is the IEC 619689 standard, which uses CIM elements, and that allows for much better integration between components such as the MDM and the head-end system, but to other components as well, such as the CRM system. If all of this seems a little bit loony to you, you're not alone.
Does this answer your question?
Clearly you've got staying power, so in part 4, I promise to simplify all of this by providing 3 recommended smart models.